Hello guys, today we are discussing isotopes and isobars. Now on today's new lesson on calculation in chemistry, we need to quickly visit some of the things we learned in our previous lessons. Now in our previous two lessons, we worked on relative molecular mass, that's molecular mass, and just in the most recent lesson, we worked on percentage composition. Now we need the knowledge of these two major things we worked on in our previous lessons to understand what we're about to discuss today. So today we're going to be discussing isotopes and isobars. So what are isotopes or what's an isotope? So an isotope is a phenomenon whereby the various atoms of an element have the same atomic number, that is the same proton number, but varying neutron number, which brings about varying atomic mass unit. So when we talk about an isotope, we are talking about a kind of condition, or I can call it a kind of phenomenon, whereby the atoms, don't forget that according to John Dalton, according to Dalton's atomic theory propounded in 1803, it was said that each element has identical atoms. That's what Dalton said. But down the line or along the line, it was discovered that various atoms of a given element could have different atomic masses, which is quite militating or quite different to what John Dalton propounded in his atomic theory in 1803. So quickly, we're going to be looking at isotope. Now we talk about isotope. An isotope, as we have said, is a condition whereby the same element, that is a particular element, not different element, the same element has different kinds of atomic masses, but the same atomic number. Now, why do we have that? The reason for this very phenomenon is simply this. Neutron number changes. As you can see, this is carbon atom. Now, this is a carbon atom, this is another carbon atom, this is another carbon atom. The same element you're talking about. Carbon is a given element, but in this very element called carbon, we have different atomic masses. Now, as you can see, this carbon 12 atom, it has here we have a carbon, here we have a 12 amine, 12 atomic mass unit. While the atomic number, which is the amount of proton, according to the lessons we took in our previous, according to the things we discussed in our previous lesson, yeah, we have atomic number to be 6, while atomic mass is 12. So it means proton is 6, which is atomic number, while neutron is 6. That's it for carbon 12. While for carbon 13, proton is 6, neutron is 7. So you can see there's a difference, a change in neutron. So neutron here is 6, neutron here is 7, and that's why we have carbon 13. It's the same carbon as an element, but this atomic, this atom of carbon, has 7 neutron, and that's why we have 13.